In this video, I want to pick up where we left off last time, creating a matrix multiplication query where I want to convert it into a function. Before getting to that, I want to say I updated the original, where I changed the final size step to, instead of simply grabbing table.rowCount, I take table.rowCount of x and column count of y and take the minimum, because you need the column count of x and row count of y to be the same in order to have the same amount of values to multiply. So in the x table we have 4 columns, in the y table we have 4 rows. But the x table says number of rows and the y table says number of columns don't have to match. But the minimum amount of those two will determine the size of the output table. Previously I simply took one value, but we have to take both. And then in this lookup table, I have to change the code where we're then referencing final size, where we are grabbing in lookupTableList. We created that list of lists, where the innermost list is the x and the y lookup values. Here we have 3 values, but I have to change that, so we're grabbing the first n values, which is final size, and likewise we're grabbing the column names of final size, because we might only have to grab the first 2 columns from y and the first 2 rows from x, basically, and then it will be the same. Which means if we now go back and change some of these dimensions to say now we're only grabbing the first x rows, 2 rows of the x table, and this should update and we should get a 2x2 matrix, because we still have the same number of columns, which we need, but now we have fewer rows. So the output is a 2x2 matrix because we have 2 rows in x. And then likewise, if we only have 2 columns in the y table, I'm again going to use the projection operator because it's a little faster than table.selectColumns. Again, we end up with a 2x2 matrix. But otherwise I haven't changed the code. As mentioned at the start of the first video, I can't convert this into a function. Well, I kind of can, but it doesn't reference any parameters, and then it doesn't really work properly. Instead, I will have to change the query, and then we can manually turn that into a function, which does mean that the function and the query aren't linked, which makes it harder to adapt, but just don't make mistakes and it's not a problem. We are going to create a copy of that, because we need to change that. The first thing I want to do is to take this function that I created outside of the query inside of the final function, because I want this to be one code basically that you can go in here and copy that. So I don't want to have 2 queries, and then I don't want to add a step here because then the references to y are going to change. But if I go into the advanced editor and add a blank step, then the references won't update. And then in here we can change that. But then I need to change this name so that I can use func_SumProduct as a name here. And then that should be all fine and dandy, except I'm then referencing it somewhere here. Then I want to not use ABC, I want to use that one. And then it's fine. Now we can move on. And again, this x and y step are going to be removed because they will become references inside of our final query. We can call that function as query. We currently have this lookup table, which outputs the lookup positions that we do inside of the x and y table. But we don't actually need to do that because we can directly input the values instead of doing this lookup. So actually we are going to remove that lookup into XY step, and then this is going to fail, but that's fine. So we can save this again. And I want to change this step because this needs to be the direct lookup. And then we need to update this code instead of creating that list of lists of zeros and ones and twos and so on to do the lookup. We are going to change that to do a direct lookup. And I'm just going to add indentation to make things a teeny tiny bit easier to follow along, because it's kind of hard to have 2 nodes open at the same time. We are outputting row state, which is fine, but then instead of row current, we need to directly do the lookup. So we need to write x to 1 column, and we are grabbing the value from that row of the index that we're iterating over. And then likewise, instead of here called current, we need to say y to 1 row. Then if I did everything right, then that gives me a record, and that is because this needs to be a list. And then we get the lookups as records, which I need to check if that's what I want, which I don't want. We just delete these for a moment, and then we can try to extract that value. And we see, that's because I need to do references. That is because I changed this, instead of being y to 1 row, I changed it to be y to 1 list in order to have the same lookups. First off, I wrap this in table.transpose, and then we can add indentation. On top of that, we are then extracting So I need another parentheses. And then this will output column 1, and then we want that as a list because, yeah, I decided to turn these into lists, which I'm sure I had a reason for. I think it's because we're using so many list lookups that it makes more sense to have them stored as lists. It means here we need to extract the A column. Now we have a list, and then here likewise we extract the column 1, which is a default column name, so that can be hard-coded. And here in the X we manually decide to call it A, so this can be hard-coded. That's not a problem. And then this should output lists. Then we get list of lists, which I think is what we want. Yeah, because we need 3, 4, 5, 6, which is then the third row, and likewise the second one is 5, 6, 7, 8, which is the first column. So that is what we want. Yeah, like I said, I think it's because it made more sense to me that we're operating on lists. We're using so much list accumulate and list accumulate and list repeat that I thought it made more sense to have the X table and the Y table stored as lists, instead of a 1-column table and a 1-row table, just to have the same dimensions. But now we actually have to add back in the step I deleted, the sum product step. So that was a bit of a mistake. So we're just gonna write that manually. We're gonna need the column names, do a transformation to each column as before. And that is from the previous step called that func list. We accumulate over 0 to final size -1 because lists are index 0 based. Start with an empty list of transformations. Our function is always state comma current. It goes towards, and we're going to say output the state, the value that we change, and then we need a list of lists because table.transform columns takes a list of lists where the inner list is then each column, that is the transformation. And then we do a lookup into column names with current, that is our iterator, and our function is to use func sum product, which is then stored as a step where we input _0 the X and then _1 for the Y, and then we can output type number. I think I forgot, and then we actually need to perform the table.transform columns, and then our list is func list, and then we get the outcome that we expect. So that's good. We call that calculate sum product, and then finally we need to add back our validation check, which again is to check if check size equals true, then output calculate sum product, else valid dimensions. Unfortunately, I pressed Shift 1 when I wrote invalid dimensions, which means my recording paused. So we're gonna go back to when I wrote that check. Hopefully this makes sense. So we wrote if check size equals invalid dimensions, and then our actual query is done, and I checked that if you change the dimensions of X or Y, everything is fine. You either get invalid dimensions or you get a 2x2 matrix or 1x1 matrix. Everything works, even if I didn't show it, but I'll show it when we turn it into a function. What we can do is, if our first steps are the names of our variables, then we can copy this, go into advanced editor and start by adding indentation. And we add an outer layer of let, which is then going to be ABC. It doesn't matter, that's the name of the step. Then we can take our variables here and remove them as steps and instead say they are referenced in our function. We say this function goes towards our inner query. Then we need to add in here at the end to say now ABC is a function that takes two parameters, x, y, and those are referenced here, X and Y, and so on. Inner query outputs valid size check, which ABC is then set to equal. So we can change this to be func matrix multiplication, and then we can test it by referencing it. To say first we input tbill X and Y like normal. We get a 3x3 matrix as expected, and if we get fewer columns of the X, we have invalid dimension. And if we have fewer rows of Y, then we also have invalid dimensions. And then if we have fewer columns of X, actually now I'm confused. If we have fewer rows of X, then we will have a smaller array, or I should say matrix. We end up with a 2x2 matrix. And likewise, we have that problem with Y, where we only have 2 columns. Then we also end up with a 2x2 matrix, but otherwise it's fine. And yeah, I don't know when you would use matrix multiplication. I'm not a mathematician. My only example would be if you had months, so 12 months, and you had to multiply each value by a value based on the month. So you would have January have to be multiplied by January value and February by a February value and so on. Otherwise, I don't really know when you would use this. But now you have a function here, so I should probably store that somewhere. So yep,